Hello guys, this is Rydon Academia, and today we'll be looking at a very important topic: equation of a straight line passing through a given point and parallel to a given straight line. In our previous video, we've treated gradients. We have also treated equation of a straight line when 2 points are given. But here we are giving that only 1 point is given, and then we are also giving a straight line which is parallel to this equation. Okay, now the first thing I want us to note is our formula for finding equation of a straight line, which is that our gradient is equal to y minus y1 over x minus x1. Okay, if you've not watched our previous videos, please search for them and do so. Alright, so then you understand how come we have this formula. Alright, so this is the first thing to note, is our formula for finding equation of a straight line. And the next thing to note, now since we are dealing with parallel lines, you must know that in parallel lines the gradients are the same. That's the gradient for the first parallel line, which is our m1 in this case, and the gradient for the second parallel line, which is given. They both gradients are the same. Okay, in the case of parallel lines, we have that their gradients are the same. So with this, we can now take a question and solve. Alright, now from this question, we are asked to determine the equation of a straight line parallel to the line 5x plus 4y is equal to 12 and passing through the points A, which we have 3 and 5. Now, this is our equation. Okay, we are asked to determine this equation, and the first thing we have is that it was passing through a line 5x plus 4y is equal to 12. Okay, and this is the line it is parallel to. This is the equation it is parallel to. And then the second part of it, we were only given 1 point of that same line, and then the point, and that it passed through this point A, 3 and what 5. We're not giving point B, we're only giving point A, and we are asked to determine this equation. Alright, so the first thing we will have to do, like we always do in our video, is first of all to find our gradient. Now since we are not given 2 points, okay, we'll be finding our gradient from this straight line function given here. We'll be finding our gradient, and then we'll be using our gradient to solve for the equation. Alright, now in finding our gradient, like I said, our gradient is the coefficient of our x when our y is subject of the formula. For us to have our gradient from here, it means our y has to stand alone. So I'll be taking x the other way. Alright, so we'll be having, from that, we'll be having that 4y will be equal to, when 5x goes the other way, it becomes minus 5x. Alright, and then we have plus 12. And then our 4 is not yet subject to the formula. So we'll divide all through by 4, okay? We'll divide by 4, divide by 4, and divide by 4. So we have that y is equal to minus 5 over 4x plus 3. Alright, with this now, like I said, our format remains what y is equal to mx plus c, where m is our gradient. So the coefficient of our x is our gradient when y is subject to the formula. So with this, we can say that our m is equal to minus 5 over 4. Okay, this is our m. So we can use this now to solve for our equation on this straight line. Like I said, when the lines are parallel, our m1 is equal to m2. Okay, this is our m2 because it was the line that we were told it was parallel to. Okay, it was parallel to, but what we are looking for is the equation on the line with m1. Alright, so quickly, since m1 is m2, it means m1 is also minus 5 over 4. Okay, so in solving for, we are going to be using this formula right now. In solving for our equation on the straight line, to get the equation on the straight line, we're having that our gradient is y minus y1 over x minus x1. Okay, so we'll quickly put that together. Our m is equal to, our m now is given to me minus 5 over 4. Okay, is equal to our y. Now we're only giving a point, right? So this is just our x1 and our y1. We're only giving 1 point. Okay, so it fits perfectly into that formula. So our y1 is 5, and then we have x minus, our x1 is 3. Alright, so what do we do next? We cross multiply. So in cross multiply, like I said, our y will have to come first. So y times 4 will give us 4y. Y times minus 5 will give us minus 20. Minus 5 times x will give us minus 5x. And minus 5 times minus 3 will give us plus 15. Are we together? So what to do next is to collect like terms. So we'll be having that 4y is equal to, now when this moves to the other side, we'll be having minus 5x plus 15. Now this is a minus, it will become plus 20. Then we'll have 4y is equal to minus 5x plus 35. So this is our equation on the straight line, which we have gotten by simply solving. So we'll only be taking one example for this class.
Continue.
Alright, so if you look at this very well, you can, if you also divide this all through, right, you divide by 4 to have your y standing alone, you will arrive at the gradient, which will be minus 5 over 4, okay? Alright, so with this example, we've come to the end of equation on a straight line passing through a given point and parallel to a given straight line. So please look at this very well. If you've understood our video, give us a thumbs up, subscribe to this channel, comment on this video, share to others. Thank you very much.